And welcome back to part 2 of how to move from a schematic diagram to a PCB like this. Now, last week we'd got to the point where the schematic was complete, we'd double checked everything, we knew what the components were going to be like, and we were just about to place them on a PCB. So let's rejoin the main video at that point. So what you do, you come up here and you say convert to PCB. Click that. Now what that's going to do when I click it is to check that each of these components has got a footprint, because otherwise it won't know how to place it on the board. So let's just click that and make sure it works. Footprint, yeah, what is that? Well, each component must have a description of all its physical attributes. So you've got pads, pins, the spacing between them, the overall size of the component, including the clearance that it needs around it. They're all required if we're going to place this on the PCB. Now, as you'll see here, off-board components like our rain sensor can be represented by just a couple of header pins. Well, obviously it did work because now it's placed a nice little, what it thinks is a default board size here in purple, and all the components here laid out for you to place on the board because it doesn't know how you want them. Now over here behind my head, so I'm going to move this over, this little device here is very important for you, and it talks about the layers of your PCB. Now remember, your PCB, if we start with the fiberglass layer in the middle, you have a top copper layer and a bottom copper layer. Okay, and that's what the top and bottom here are talking about. Top is always red, bottom is always blue. Well, it has been in my experience. I don't know if other programs use different colours, but you can change them anyway if you really wanted to. Now, okay, that's the top and bottom copper layers, the actual conductive layers, but then you have also the top silk layer, the silk being the bit you see, the writing, the white writing on the board. You can also put writing on the bottom of the board, as you've probably seen with a few of mine. I put instructions on the back and labels and whatever. Okay, and the top paste mask layer, and all these you probably won't be touching at this stage, not until you get a little bit more advanced. And all the way down here to document and multi-layer, you won't want any of those at the moment. So it's probably the top 4 you want, because even though you have a top layer of copper, on that copper there'll be a top layer of solder masks. That's the green stuff, although you can change it in JLC to any other colour you like, to protect the copper layer and to stop the solder sort of spilling out onto bits it shouldn't be on. Now, you have to make sure that this little pencil icon here is on the right level for you to actually edit that layer. If you start typing in text on the top layer thinking that's the silk screen, you'll get your text come out actually in the copper. Who would do something as stupid as that? Yeah, alright, I did it on my first PCB because I wasn't au fait with all these layers. But believe me, I learnt the hard way. Now I know. Okay, so the top and bottom layer is only for the conductive layers, and the top and bottom silk is only for the writing. Okay, right, now we don't want to know anything about those yet because we're not ready for any of that sort of track information. What we want to do is place these components on here. Now I would say place them pretty much like your circuit diagram. One, because it's easy to understand later when you're looking at the PCB, and presumably you've placed your circuit diagram components in a particular way for a particular reason. After all, if you've got a transistor with a resistor going to its base, as we have, you don't want the transistor at one end of your PCB and the resistor right over here on the other end. It just wouldn't make sense, and you'd have a hell of a time trying to trace it out in your own mind later on. You think, why on earth did I do that? So keep it fairly similar to the way your circuit diagram is. Right, let's start off with the biggest component in it. This is the CR2032 coin cell battery holder. So I'm just going to move that over here. Now, as I'm moving it, you're seeing these white lines that then turn blue when I let go. Those lines are called rat's nest lines. Now, a rat's nest, in real life this is now, nothing to do with PCBs. If you've ever seen a rat's nest, it's lots of hay and straw, all miggledy-maggledy put together. Yeah, that was a technical term. And, you know, there doesn't seem to be rhyme or reason, but it does, of course, make something at the end of the day. And it means something totally disordered. So, and that's what this is. What it's trying to show you is that this top connector here, if I move it you'll see it better because it goes to white, is in fact, look, it's got a rat's nest to the buzzer connector. So this blue line here is going to the buzzer. It goes, well, I know that's connected to it electrically, or will have to be. So I'm just showing you really, you know, roughly, because that helps you place your components. I'll show you in a minute. Right, let me just finish placing these components on here, pretty much like we had on the circuit diagram, and I'll be right back. So here we have a very rough and ready layout. Don't want to worry too much because you can always nudge things into position and line them nicely. So this is roughly the way it's laid out in the circuit diagram. You've got Q1 down here connected to the buzzer, Q2 up there, resistor capacitor. You'll see that it corresponds pretty much to the circuit diagram. Now if there's not enough space, in fact this capacitor looks absolutely ginormous. I'm sure that's the wrong one we've chosen there. The royal we, that is, obviously. It should be tiny, but never mind. Just goes to show what I mean by making sure you've checked your components properly, doesn't it? Space things out nicely because you don't want to cram them in too much. I'm doing a PCB at the moment where they really are crammed in, but eventually, not straight away, get them roughly aligned first of all. And there are alignment tools. If you think I'd like my things really lined up nicely, for example, I'm just left clicking and dragging those two resistors, which obviously didn't work. Okay, I'll do it manually. If you use the if you click something and then click something else with the control key down, it will select those two. You can align them using this tool up here. You can say align left, line right, top left, whatever. Let's align these two left. And in fact this capacitor, the outline of this capacitor is encroaching upon this pad here, so that wouldn't be allowed anyway. So we'll move that out a little bit. There we are. Now you can spend forever and a day prettifying this board, but first of all I'd say get it up and running first. So having done that, you think, okay, is there anything that looks a bit odd? Well, look at this battery connector that I'm wobbling about here deliberately to set the rat's nest lines white. And you can see that they're crossing. One goes down here and one goes up there, which means this thing is the wrong way round. We should flip it vertically. So I can either press rotate a couple of times. There we are. Or you could have used rotate up here. Here we are, rotate left, rotate right, whatever. So now you can see that the lines don't cross, and it does make the routing a whole lot easier. Ditto, this transistor seems the wrong way around. Be better if we turn that round. There we are. Now you can see that the lines don't cross, and it just makes routing a lot easier again. So let's assume now you've been planning about this for a while and think, yeah, that's good enough. Now you can either wire this up yourself, which lots of people do, therapeutic it may be, or you can think, no, I haven't got time for that. I'll let the system do it. So what you need to do is go and say auto route, please. And even if the auto route isn't totally to your liking, you think, why did it do that? You can always amend it afterwards. So let's do the auto routing. So from this menu here, we check auto router. Now what it's going to do here, what it asks you here is to say how wide does the track have to be? Well, from JLC, I believe the minimum might be 5. You'd have to actually go onto their website and look at their specifications to say we can only do it this wide. In fact, I seem to remember you can get it all the way down to 3 if you want to pay more money, because obviously getting a track really, really, really fine means they're probably going to have some boards that don't quite meet the spec, and they have to throw those away. So they charge you more for that. I think the minimum is 5, and I don't know who goes below 5. I guess somebody must, otherwise they wouldn't even offer it. But we're saying here at the moment 6, but we'll come back to that. 6 mil this is, so the units of measure up here is mil. That's thousandths of an inch. You might not want to work in mil, you might want to work in something else, and you can change that as part of the preferences to this entire program. I tend to work in mil though for this. Via diameter and via drill diameter minimum also is in the JLC specs about what you can do, but these have already been set. Okay, right, let's run the router and see what it does. And auto router is running, and that was quick, done it. So the red is the top, so you can see these red ones are all connected up. The blue ones underneath, they've gone under the board, although frankly. I think they probably all could have gone on top. So I mean about auto router, you can check it. Look, this one here, they've made this one go under the board to here, but you could easily have routed it from here between this capacitor and down here on top if you wanted to. Okay, there's nothing to stop you saying no, I don't want to do that. Now that's fine, it had no problems, and this, if you sent this off as it is now, it would work. It wouldn't be the prettiest board in the world, but it would work. Now because there are so few tracks on here, these tracks do not have to be that narrow. And this isn't talking about microcontroller type tracks where you have dozens of them coming out. So what we could do is say, well, let's auto route again, but this time we're going to have wider tracks. We're going to have 20mm tracks that just make it look a little bit more sensible. There it goes. It's done it again. Same routing, of course, but this time in wider tracks. Makes it a little bit more sensible. Now there's one final thing we need to do. By convention, you would normally have a ground plane on the underneath of the board. So the bottom copper layer would all be ground where it can fit it in. Now don't think this is some magical shortcut, because if you can't connect point A to point B anyway, then the ground plane's not going to connect to it either. Okay, what it means is, instead of getting rid of all that copper underneath and just connecting point A to point B, it will just leave all the copper as much as it can underneath, except where tracks run through it, and it will still connect point A to point B. All right, but if it can't connect, then the ground plane doesn't give you any added advantage in that sense. What it does do is give you, well, first of all, it gives you a ground plane to prevent spurious RFI and EMF transmissions, which probably in a microcontroller might help, certainly in NRF 24L01 type projects, or even anything with the Wi-Fi, ESP8266, ESP32, they probably all transmit like mad. So putting a ground plane at the bottom is probably a good idea, and possibly even at the top as well. So you can have two ground planes, top and bottom, and okay, that is considered good practice. And secondly, of course, what always concerned me was, what do they do with this copper they're etching away? Do JLC actually recover that copper, or does it just get flushed down some drain somewhere? And I'm thinking, well, the less copper they have to take off must be better for the environment as well. So I tend to leave it on. How do you do that? Good question. Now, I said at the bottom layer of the copper we're going to have as a ground plane, but it's only going to be ground if it's connected to ground in your circuit. And so far on this diagram we hadn't connected anything to ground. So what I've done, I've put this little thing here to say this negative connection to the battery, consider that to be ground, GND, as a net. If you look over here, if I connect, if I click that whole piece of wire there, that is all going to be connected to this one, which is ground. You can see the name up there is ground. It's a net being a piece of wire from A to B. Every single connection on this diagram has got a net or a name, okay, but net is the word we tend to use, and all those names are unique, and it basically tells the system and you what connects to what. Now normally you don't have to worry about that too much, but certainly when you get to microcontrollers, every single pin will have a different net name. So on an Arduino Uno, for example, you'll have a net of A0 and another one of A1 and another one of A2, so that they connect to the correct header pins that have got the same name. Now here, because we hadn't got a ground net, I've put one on. That's what that ground symbol there does, and I've picked that up from over here, just behind my head. By picking that up, selecting it, I can then drop a ground on there just like that. That's useful because when we come back to our PCB, I want to create or tell it that the back layer of copper on here we're going to have as a ground plane, and wherever this negative value of the battery is, just connect it to that. So it's on the back, so we need to say bottom layer. So over on this one we have to select bottom layer, and then in the PCB tools we say I want this one here, which is copper layer, copper area. Luckily for us, we don't have to be that exact. When we do this, we can say, well, somewhere around here, and I tend to put the back one pretty much about the size of the board, because automatically it will remove it from the edge of the board. So I go, okay, from there to about there to about there. You can probably see the blue line behind me, to about there, and then right click. Oh, there we are. Look, it's built the ground plane. Now these other tracks, these here that are highlighting now white, they're not ground, so they are obviously etched out of that ground plane to make sure they're not connected. But all this blue you see here is all the negative terminal of this battery. And you can do just the same to the front if you want. And over here, this ground plane, if we select it, we can see that the fill style is solid. Do you want to keep islands? That means if it gets a bit of the board where it can't connect to another bit of the ground plane, do you want to keep this bit of copper in the middle that isn't connected to anything? And the reason you might want that is because then you can manually connect things to the ground plane, but normally you'd say, no, I don't. It would just take away the copper from that area. Okay, that's probably a bit beyond what we need as a beginner, but I'll leave that ground plane on there. And if I go back to the top layer, you'll see it lays on top quite happily. Cool. What else can we do? 3D viewer, very, very useful. Right, before you say, yes, this is okay, I'm going to send it off, go to the 3D viewer, because that can give you an insight into how it really looks in real life. Now, they've speeded this up in EasyEDA. A few months ago, it was torturous getting a 3D view. It just took so long. But now it's really quick. Not yet interactive. So if you make a change to the PCB, it will not show up in this 3D view. You have to go and create another 3D view. But now, because it only takes a few seconds, that's not too bad at all. So this is what it's going to look like in real life when you get it back. This white ink is the top silk layer, and you didn't have to do that because the people who created all these components automatically have done that as part of the footprint. You can put extra writing on here, of course. But I'll leave that to you. It's just text on the silk layer. Don't put it on the copper layer. And on the back, I don't think we've got anything. But what you can see just about, especially if I zoom in, all this here where my mouse is now going over, all this is solid copper. Admittedly, it'll be under the solder mask, so it's difficult to tell that it's copper, but it is. All this is copper, and it's all connected to the negative of this terminal here. And if we zoom right in on this terminal, like that, this component hole that goes through the board, connecting that negative terminal, so the little prong on that component pokes through this hole, and it's connected, as you see here, via this copper here as a spoke design, because we've told it when we created that back plane, make the connections spoked. And I'm not going to go into why. Let's just keep it as that. It's best practice. Okay, spokes. So there we are. So that's the only connection to ground here, except where other grounds are required, like here. There's one as well. Look. So that's connected to ground. So that's the same as having a connection between that point there and that point there. If that could not be connected to that point there, because maybe there were other tracks in here, then putting the ground plane on doesn't help one little tiny bit. It's not going to magically connect it. Okay, so that's why the ground plane is normally put on last. Right, so that's it then. So there's your PCB pretty much as it's going to appear in real life. In fact, I'd say exactly how it's going to appear in real life. Right, so you can send that off now. Now there's two ways of doing this. Either you click this button here to say JLCPCB. So clicking that button brings you here to their main screen. You enter the details here, but frankly, I'd leave this as is. You don't need to worry about the dimensions. Your Gerber files will tell them exactly how big your PCB is. All you need to do is choose the number you want. I'll put down 5. It's always going to be 2 layers. You don't want a board thinner than 1.6, and then hit the quote now. Now, once this loads up, you need to basically upload your Gerber files, as it says here, add your Gerber files, which you've generated them from EasyEDA. But rather than faffing about here, let's think about a different way of doing that. Instead of doing all that, what you can say is, from your PCB, so let's save that. Right, I'm going to save that. Fine. Now, what we can say is, I want to generate my Gerber files. What are Gerber files? Well, they're about 7, possibly 8, maybe 6, depending on what you're doing. Textual descriptions of this board. So it tells it how big it is, where the drill holes are, whether the drill holes are plated or which ones are plated and which ones are not. So your mounting holes probably are not plated. It tells it where the solder mask goes up to and stops. It tells it where the tracks are, and the silk layer, of course, all the white ink and stuff. It tells it basically everything it needs to know to create that board. And there's about 7 files. Now, normally you'd create these Gerber files, zip them up, and then send them off to JLC as part of that board upload. But because you're using EasyEDA, you can say, create my Gerber files, this one here, generate fabrication file, Gerber. Click that. Do you want to run a DRC check, it says? Yes, you do. The design rules check is absolutely essential, and you should be running this while you're doing the board. But because this one was so simple, we just sort of left it to the end. So we do want to run it. So it's obviously passed because it's now leapt on straight away to say, right, this is what you've ordered. Here's your dimensions. That's why I said you don't have to be that accurate, because it'll always work it out for you. How many do you want? Your PCB thickness, which is always 1.6. Green colour, but you can have any colour, I think, from JLC. But green is quickest. You'll get it quicker. Surface finish, hot air soldering levelling with lead. With lead is better, frankly, because your solder will stick to it better. Copper ounce, we don't want any thicker than that because it costs a fortune. And your PCB price is $4 for 10 pieces. Now, just think of the environment a tiny bit here. If you think I'm only ever going to build 2 of these, one for me and one for my mum maybe, then maybe you should put that down to 5. You always need a couple of spare just in case, but it does seem a little wasteful to make 10 if you're only ever really going to use 2. Okay, so the estimated time for delivery is 3 to 7 days, and look, you get $8 off your first components order from LCSC. Definitely want to take advantage of that. Now, you can either generate your Gerbers here by clicking that and have a look at the Gerber files. So what it does, it reads those Gerber files and shows you what it thinks it is, which should be exactly the same as that picture. Or you can just go straight to JLC at this point here, click that button, and it will take you straight to JLC, upload your files automatically, so there's no Gerber file generation involved, and that's it. You just click, I'm done, basically. Let me make this a little bit bigger. So what it's doing now, look, it's adding your Gerber files automatically, and there we are. So JLC now know about your board, and there it is, pretty much as we had it. Well, I say pretty much, exactly, so the thousandths of an inch as we had it. Okay, and it's $4. Now, of course, as like everything coming from China, it's the shipping that will cost you. The board charge of $4, frankly, it's only just more than a cup of coffee this time. Probably a coffee and a half, or maybe 2 very small coffees. But the delivery for DHL, which takes, in my view, about 2 to 3 days, is near enough $20. Now, there are cheaper options. If we click that option, there's GB Special Airmail, which I used once, and that worked. That's only $8. Postlink GB Registered Mail, $5.30. And obviously this is talking about United Kingdom, because that's where I live. If you live in Australia or America or somewhere, it will come up with some different options. But the quickest is DHL, but these others do work if you're prepared to wait a little bit, and then you save money, whatever's most important to you. Cool. So having said, yeah, this is fine, you can come down here and look at the options, but I'd be surprised if you had to change any of these, especially being a beginner. You probably don't want to fiddle with them. Just leave them as they are, frankly, and save to cart, and it will say, okay, pay. I think you get an option to either pay straight away and they'll tell you if there's anything wrong, or you can say, I'll wait until you've told me it's all right before I pay. Whichever way round. If you pay straight away, the instant they've given the nod to this design, they'll get on with production. Otherwise, they'll look at it, go through it, going, yeah, that's fine, send you an email or something and say, it's fine, please pay. You've then gone to bed or out, and half a day goes by that you've effectively wasted in production time. So make your choice on that one as well. And that's it. You can order the components then, also the BOM, B-O-M, Bill of Materials, your shopping list from LCSC. Get your money off if it's your first order. But as I say, the component cost, I think it was, what was it, $2.41 or something like that? I can't remember now. That is not the issue. Once again, it will be your delivery and you have to choose the one most appropriate for you. Well, that's it. Now, if you're a beginner and you've never done this before, it will probably take you the best part, I think, of a week to get to grips with this, because you don't just want to get to the end result and go, that's it, I'm never going to do it again. You actually want to become familiar with the program, starting off with the schematic circuit diagram generation and selecting your components from LCSC. Make sure that's nice and fluid and you understand what you're seeing in that selection panel, the voltages for the capacitors or the size of the resistors. You do not want to select a 2-watt resistor when you're after an 8-watt resistor. And in fact, like our design here, funnily enough, we've got this massive capacitor in the middle. Now I know that, what was it, 100 nanofarad? No, it's a 10 nanofarad capacitor. It's the size of a gnat's egg. It really is. It's tiny. So why I selected this one? Well, because it's a demo and I'm rushing without looking at doing things. But if you get to the design stage and you go, what on earth is that? Then you know you've done it wrong. You need to go back to the schematic, replace that component, and then import the changes into your PCB, which is very easy. In fact, we can do it now, look, just to prove. If this is your PCB, let me just get rid of this, give us a bit more room. There we are. Up here, this little thing here, where it says import changes. Now, when I click that, I'm hoping it's going to say there are none. No change. The PCB already matches the schematic. Hooray! So we know everything's fine. But if you change that component, that C1 component, it would actually say at that point, remove C1, insert C1, or replace C1 it might say, and it would be a totally different size and the tracks wouldn't match up anymore. So you'd either have to go into manually repair those or just use the auto routing function again. Simplicity itself, but you just need a little bit of practice to do that. Cool, there we are. So that's how you make your first PCB, and I guess the first time you can just do it as though you were going to order all the steps until you think, yeah, I've got the hang of this. Now I can do a real circuit, something I actually want to make, rather than the rain sensor that I don't care about one way or the other. And soon enough you'll be producing boards at least to this standard. I mean, this is nothing special, believe me, but it's my Benny cupboard thing and it seems to be working. I'm just waiting on something to finish that off. Time, mainly. I think I'm waiting for time to stop so I can get on with a few things. And as I say, I've just had this one here come through, which is assembled, partly assembled, SMT assembled, which I'm dead keen to get cracking on, but once again it's finding the time. This is my universal timer. And as I say, if you're a beginner at PCB making, just think 10 months ago I didn't know one end of a PCB from another. Now I'm doing this sort of stuff. It's just practice at the end of the day. Cool. I hope you like this video. Do practice, do have a go. It's a real change of thought process, really. And then finally, yeah, like you're going to have to pay something, unfortunately, to somebody to get the components and the PCB, but it's so worth it at the end of the day. Great. I hope you liked it. Give me a thumbs up if you like it. It tells YouTube that it was worth it. It's more to the point. That's the good thing. Comments down below. And I'm sure you experienced guys have got lots of things to say about this. And you non-experienced guys, if you're just starting out and you've got queries and questions and you think, what about this and how about that? Fine. Stick them down below. I'll reply over the next week or so. Okay, that's it then. Okay, thanks for watching. See you in the next video. I hope you're finding these videos useful and interesting. There are plenty more videos to choose and a couple are shown below. And if you'd like to subscribe to this channel, just click on my picture below and enjoy the rest of the videos. Thanks for watching.